Okay, so now we've successfully set up the car simulator class. We haven't written much code yet, but the car simulator already contains the entry point for this Java program. And by entry point, I mean the first lines of code that will be executed when the program is fired up. These first instructions are the ones inside the main method. Now, you might ask, how come we've never seen a main method in our Android apps? Android apps are written in Java after all, right? The reason is that when you launch a standard Java program, you start a Java virtual machine, or JVM, which will look at this main method and execute the code inside. But Android has its own virtual machine called Android Runtime, which replaces the JVM. Android Runtime, together with the Android operating system, is what's responsible for starting things up and managing an app's lifecycle. Android determines the entry point for your app by looking at the Android manifest file. This is the XML file in your project pane that has information about what your app's about for both the Google Play Store as well as for the operating system. Android will look at this XML file and find an activity that's marked with a special flag, namely android.intent.action.main. This is the so-called intent filter and designates an activity in your app as the entry point. After all, your app might consist of more than one activity, so Android has to figure out which is the main one. The Android operating system then calls the onCreate method of the activity that's designated as the main one, the one that's flagged as the entry point for the app. So both Android apps and standard Java programs have a certain bit of code that will be executed first when the program is fired up. It's just a little bit more straightforward finding the entry point with a bare-bones Java program. The one thing I introduced in this explanation but I haven't really explained is what I meant by virtual machine. A virtual machine is an emulated computer, or a computer system that only exists as software. You might be familiar with products like VirtualBox or VMware that allow you to run Windows on Mac or vice versa. The idea behind the Java virtual machine is quite similar. But why do we need a virtual machine for Java in the first place? Well, the thing to understand is that at the hardware level, computers don't really understand Java. Instead, the computer hardware actually requires instructions in machine code, which tells it, amongst other things, what to do with its registers and memory. The problem is that machine language looks something like this. It's not only hard to read, but different types of hardware actually require different machine code instructions. Programmers who write software in machine language actually have to specify which bits of data go into which slot of memory. So a new piece of hardware, say one with more memory, requires a whole new set of instructions. In other words, each program written in machine language is specific to a particular computer architecture. And that's why in the olden days, programmers had to rewrite entire software just to get it to run on a different device, which of course was a massive problem. Java came along with the idea that a program should be able to run on any device, no matter what hardware it has or what operating system it's running. To accomplish this, the Java virtual machine was created as a go-between between the hardware and the code written by the programmer. The idea was that any computer could run a Java virtual machine, and the Java virtual machine, in turn, knew how to read and interpret what the programmer wrote in Java code. So then, the Java virtual machine could take the Java code written by the programmer and translate it into machine language instructions for whatever device hardware it was running on. Looking at the world today, Java has definitely accomplished its mission from this perspective, which is why Oracle can't stop bragging about how many devices are running Java in their download wizard.